Hi everyone, in this video we are discussing problem number 20, valid parenthesis from LeetCode. So this is an easy problem, but it's not going to be that very easy if we do not know the concept of stacks, right? So you will understand it when we are actually devising the algorithm, right? Okay, so let's read the description of the problem. It goes like this. Given a string S containing just the characters, so these are the 6 possible characters the string S may contain. So what are those 6 characters? So we have opening parenthesis, we have closing parenthesis, we have open curly brackets, closing curly brackets, open square bracket and closing square brackets. Okay, so these are the 6 possible characters the given string S may contain, right? It doesn't contain any other character. Okay, now we have to determine if the input string S is valid. And they're also giving a description of what makes that particular string valid. So we have 2 simple conditions. Number 1, open brackets must be closed by the same type of bracket. So if we see opening parenthesis, there must be a corresponding closing parenthesis. And if we see open curly brackets, there must be corresponding closed curly brackets. If there is a square bracket, open square bracket, there must be closing square bracket. That is the first condition. And the second condition is open brackets must be closed in the correct order. So the first condition states that every open bracket must be closed. And the second condition states that it must also be closed in the correct order. Okay, so they have given some examples. We'll just quickly go over these examples to understand what they mean. But it's quite intuitive. Okay, so the first string is this, right? It is a string of length 2, as you can clearly see. So we have opening parenthesis, we have closing parenthesis. So this open parenthesis is being closed and it's also closed in the correct order. So it's a valid parenthesis. We will have to return a Boolean. The output that they are expecting is a Boolean, right? Okay, look at this second example. So we have open parenthesis, we have closing parenthesis, we have open square bracket, we have closing square bracket, we have open curly brackets, and we have closing curly brackets, right? So it's a string of length 6 and every bracket is being closed and it's also being closed in the correct order. So even this is a valid parenthesis. The answer is the output is going to be true. Fine. Check this third example. We have open parenthesis and we have a closing square bracket. So this is clearly invalid, right? Because this open parenthesis is not being closed by the same kind of bracket, it's being closed by a different bracket. So this is not valid. Check this fourth example. Okay, a string of length 4. So we have open parenthesis, we have open square bracket, we have closing parenthesis, we have closing square bracket. So every bracket is being closed. So that is not the problem. But the problem is it is not being closed in the proper order, right? It's not, you can look at this, okay? This open parenthesis is being closed here, right? And this open square bracket is being closed here. So it's like these 2 brackets are being entangled. They are not closing properly. So even this is an invalid parenthesis. It's an invalid string. Okay, so the output is going to be, again, Boolean, false, right? Now check this example. Open curly brackets, open square bracket, closing square bracket and closing curly brackets. Every bracket is being closed and they're also being closed in the proper order. So again, it returns the Boolean true, right? Okay, then let's head over to the whiteboard to see more examples, just 2 more examples, but I have purposely taken a very lengthy string so that we can understand what is going on, right? And I have taken 1 example for each case. 1 valid string, 1 invalid string. Okay, now with the help of these examples, we are going to devise an algorithm which tells us whether it's a valid parenthesis or not, right? Like I told you before, we are going to use the concept of stacks, without which this problem can be super complicated, right? The concept of stacks, the usage of stacks is what makes this problem easy. Otherwise, it's not a very easy problem. Okay, let's discuss the first example. this particular string. Okay, of course we need a stack, and this is how we are going to solve this problem, right? So we are going to scan through this entire string. Okay, just one linear pass is enough, right? We are going to come up with a linear solution. Okay, the time complexity is going to be just O of n, right? So take the first character in the string, which is this curly bracket, open curly bracket. Okay, I'm putting it in the stack. We are appending it to the stack. So as you know very well, the property of stack is that we are going to always append things to the end of the stack, and we are going to pop off things from the end of the stack, right? Okay, so we included this in the stack. Now go to the next character, that is open parenthesis. We are putting that in this stack. Then we have this open square bracket, include that in the stack. Then we have this open curly brackets again, include that in the stack. Then we have this open parenthesis, include that, open parenthesis, include that, curly brackets, open curly brackets, include that, open square bracket, include that. Now we have a closing square bracket, include that. The moment you include that, we clearly see that there is a match. Okay, this open square bracket is properly matched by this closing square bracket. So this, whenever there is a match, we are going to pop off those two elements, right? The last two elements in the stack, we are going to pop off as and when the brackets are matching. Okay, so we are removing that. And we are continuing with our linear scan. Okay, so go to the next character, which is going to be this one, right? Again, there is a match, right? After we pop off these two elements, we are including this closing curly brackets, right? That is clearly matching with this open curly brackets, which was there before these square brackets, right? So even these two elements, again, the last two elements we are popping off, right? Then what will be the next element? Closing parenthesis, and that is clearly matching with this open parenthesis, right? So again, there is a match, we're removing it. Okay, and what is its next character or the next element? Again, there is a closing parenthesis, it's matching with this open parenthesis, we are removing it. Okay, by popping off those two elements, the last two elements. Then what is the next character? We have this closing curly brackets, that's matching with the open curly brackets, so we are removing it. Then what is the next character? We have this closing square bracket, and that's matching with this open square bracket. Again, we are popping them off. Then the next character is this closing parenthesis, that's matching with this open parenthesis. We are popping it off, the last two elements. Then finally, the very last character. What is this element? It's closing curly brackets, and that's matching with the open curly brackets, and we are popping them off. And the stack is empty. And if the stack is empty, it means that the given string is valid, right? It means that this will happen. Please understand, this will happen if and only if every bracket is being closed by its corresponding bracket in proper order. Otherwise, there will be at least one element left in the stack, right? If there is no element left in the stack, then we return this boolean true. Then we return the boolean true. Let's check this particular example, the second example. So we are doing the exact same thing what we did in the previous example, right? We are going to scan all these characters from left to right, one by one. Just one linear pass is more than enough, right? So the first character is open parenthesis. We are putting it in the stack. Okay, right, we are appending it to the stack. And then we have open square bracket, then we have open curly brackets, then we have open parenthesis again, another open parenthesis, then we have closing parenthesis. Now there is a match. When there is a match, pop them off, the last two elements. Then we have closing parenthesis again. Again, it's a match. Again, we are popping them off, the last two. Then there is closing curly brackets. You know what to do, pop them off. Then there is closing square bracket, the next character is. Again, it's a perfect match, pop them off. Then there is closing parenthesis, again, pop them off, right? What is the next character? So the stack is empty, right? You see, somewhere in the middle of our linear pass, it's possible that our stack is empty, right? But once we are done with the complete linear pass, as we completely scan from left to right, by the end of this scan, if the stack is empty, only then we return the Boolean true, right? Whereas in the middle of the linear scan, it's quite possible that the stack is empty. It doesn't mean that it is true, right? You will understand as we proceed further. Okay, so we scanned till here, right? Okay, what's the next element? Open curly brackets, then open parenthesis, then open square bracket, then open parenthesis again, then closing parenthesis. It's a match, remove it. Then there is closing parenthesis again. Now you see there is a closing parenthesis. Do you see that the last pair of brackets that we popped was these two? Okay, the opening parenthesis and the closing parenthesis, right? So we pop them off. After that, the next character is this, right? I'm including it over here, right? And this are not matching, right? These two are clearly not matching, so we cannot pop them off. Do you get this? We cannot pop them off, so it will stay in the stack. Okay, what will be the next character? This closing square bracket. Okay, again, we cannot pop off anything. Then there is closing curly bracket. Again, there is no match. We cannot pop off anything. As you can clearly see here, this particular stack is non-empty. In that case, we return the Boolean false. Like I told you, as long as there is at least one element remaining in the stack, it is counted as false, right? It means that not every bracket is being closed, or even if every bracket is being closed, then they're not being closed in the correct order, right? In that case, only at least one element will be remaining in the stack. Yeah. So this is the idea, right? Now, how to code it up? How to, come up with a proper algorithm? Check this. So we're going to write an algorithm in Python. Let me first initiate a stack, an empty stack. By the way, I'm using the regular Python list as a stack, right? In the sense, I'm going to add elements to the end of the stack by using the append method. And also I'll be removing elements from the end of the stack by using the pop method of the regular Python lists, right? Okay. So we are going to scan through the given string one by one, all the characters from left to right, okay? And all those characters exactly in the same order we are going to append to this stack. In every single step, we are going to check if the last two elements in the stack is a match or not. And how exactly are we going to check it? By using this match list. So this is a list of lists, right? It is going to go like this. Please understand these are strings, right? So we will have to always put these brackets within quotes. So we have one list for the parentheses, the regular brackets. We have one list for the square brackets. We have one list for the curly brackets, right? And we'll be in every single step, like I told you, we will be checking the last two elements in the stack, and we'll be checking if those two elements, the last two elements, are belonging to this set. Okay, is it matching with this list, or is it matching with this list, or is it matching with this list, right? We'll be doing this check in every single step. For brackets in the given string s, okay, so we know that a string is iterable, right? So we are using a for loop, and bracket is the name that we are giving for the character that is currently being scanned, right? So we are going to include or append this particular bracket into our stack. Okay, stack.append that character, which we call as bracket, right? It can be any of those 6 brackets, right? Okay. And also I told you that in every single step, we are going to take the last two elements of the stack, right? And compare them with the elements in this matching list, right? And if it is matching, then we are going to pop off the last two elements, okay? So we are going to do it as follows. If stack of, how do you take the last two elements in this stack list? Stack of -2 to, if we leave this empty, it means that it is going to scan till the end. Okay, so -2 in the sense, like you know very well, like in Python, the very last element in the list is denoted by -1, and the element before is denoted by -2. So when we write something like -2 till we leave this empty, it means it is going to take these two elements all the way till the end, right? Okay, which is just these two elements. So stack of -2 till the end in, if this is found in match, if this is found in match, right? If this particular thing is found in match, then we are going to pop off the last two elements from the stack. So how do we do it? We will have to use the pop method twice, because we are obviously popping off the last two elements, right? When we call that method once, it will pop off only one element. So we are successively calling the method 2 times. So we will pop off the last two elements, right? So once we are done with this for loop, finally, we'll check if our stack is empty. If our stack is empty, then we return the Boolean true. Like I told you, it will be empty if and only if it's a valid parenthesis. Otherwise, it won't be empty. So if our stack is empty, we return the Boolean true. Otherwise, we return the Boolean false. If it is non-empty, then it means that it's not a valid parenthesis, right? Okay, now we go back to the Leetcode and check if our algorithm is working. Okay, let me change it to Python 3. So we are going to first initiate a stack, which is going to be empty to begin with. And then we are going to create a matching list. It's a list of lists, right? So the first list is for the regular bracket, the regular parenthesis, and the second list is for the square brackets, and the third list is for the curly brackets. It's not necessary that it has to be in this particular order. It doesn't really matter at all. Okay. Then we'll have this for loop for bracket in the given string s, right? We are going to append the bracket. We are going to append that bracket to the stack, and we are going to scan every single time. We are going to compare the last two elements in the stack with our matching list, right? So how do we do it? Stack of the last two elements. If this is found in matching list, then we are going to pop those two elements by calling the pop method twice. Once we are done with this for loop, in the sense like once we are fully done with the linear scan, one linear pass, then we check if our stack is empty. If this is empty, return the Boolean true, otherwise return the Boolean false, right? This particular algorithm runs in linear time complexity. I think that is the best we can do. Let's now try run this code. Okay, it's working, no problem. Now we'll actually submit the solution. Yeah, fine. It's working absolutely fine. So the runtime is not that very bad, like it's better than 72% of all the Python submissions, and our memory usage is also pretty good, right? Hope you understood this algorithm. Thank you.